Algebra lesson 5-2. So far things have been pretty easy dealing with slope-intercept form. Especially on the previous lesson, we basically were given our slope and we were given the y-intercept, and we just had to plug the values in wherever we were supposed to substitute for the m or the b. Not too difficult. The common mistakes maybe when people wouldn't watch signs, they might put something in for y instead of for b, or they might mix up the slope and the y-intercept. But for the most part, not too complicated. So we need to know what to do if we aren't always given the y-intercept. Maybe we are, but maybe we're given some other point that's on the graph that doesn't happen to be that nice convenient y-intercept. We still have to have a plan. The nice thing is, slope is constant throughout the entire graph, the entire equation. So no matter where we are with that slope, we should be able to come up with a value that'll work for us in our equation. So to start with, I'm going to give us some little steps here. All right. The first step is we want to plug in all the known values that we have. If you're given a point, remember a point is always made up of an x and a y. Okay, well, if we have an x and a y, and we're starting with y equals mx plus b, then we should be able to put that x value right here. We should be able to put that y value right here. Don't put it in for b because it didn't say it's a y-intercept, it's just any point. And if we're given the slope, that's going to go in here, which means we've got a value at y, m, and x, and the only one we don't know is b. Substitute in all the known values and solve for b. Figure out what b is going to be equal to. Step 2. Go back and substitute the original m, which was given to us, the original slope, and this newfound b, what we got from step 1, the value for b, back into this. This time we'll keep y as y and x as an x, but we'll put the given m and our newfound b in right here, and we've got our equation. We're done. That's all there is to it. We don't want to write down the given y and x. We don't want to fill the whole equation up with numbers, although it would be true. We want to substitute in just for m and just for b. So let's try it out. Write an equation that passes through the point -3, 0, and has a slope of 1/3. So according to step 1, we are supposed to take the generic y equals mx plus b and put everything we can into it. We've got an x and we've got a y. So we should be able to substitute those values. That 0 is going to go right here. This -3 is going to go right here. And this 1/3 is going to go there. That means there's only one thing we don't know. The y-intercept, the b. According to step 1, substitute in all known values and solve for b. So I plug everything in that I can into this equation, and I will now have a y value of 0 is equal to my slope of 1/3 multiplied by my x value of -3 and the b value that I don't know. Now I can actually multiply 1/3 and -3. They do multiply. A positive times a negative makes a negative, and 1/3 of -3 would be -1. So I now have 0 equals -1 plus b. I'm only one step away from finding out what the y-intercept is. Add 1, and I'm all finished with a 1 equals b. This is all step number 1. Step number 2, I now have to write the equation. I have the two most important pieces of info. I've got a slope and a y-intercept. Writing the equation should be simple now. All I need to say is y equals 1/3 x plus 1. Just like last night. The only difference between the assignment prior, the lesson prior, is before you were given this b value. Now you're given a coordinate to substitute in for x and y, and you figure out what the b value is. Then once you have the b value, it's exactly the same. You substitute in the m, you substitute in the b value, and you have your new equation. We don't want to have a finished product with anything in for x and y. We want a y equals mx plus b form. Alright, one last problem. Write an equation parallel. And remember, this is important, parallel. This will be the more complicated kind, and people get stuck on this one when they're working on the assignment. If we want something that's parallel, what must be true? It has to have exactly the same slope. So parallel means slopes are equal. And in this particular equation right here, it looks like it has an m of -3. So if this equation has a slope of -3, then our equation is going to have a slope of -3. I don't care about anything else on that equation except that my slope is the same. So instead of me saying write an equation with a slope of -3, I'm saying write an equation of a slope, or of an equation that's parallel to this equation with a slope of -3. It's just like giving you the same information but in a different way. We still have over here an x and a y. So if you think about it, you've got a slope and you have a coordinate, which means it's exactly the same as given a slope and a coordinate, you do the work exactly the same. Most people get caught up trying to do more with this equation than they should. They want to stick that 3 in for x and that -4 in for y. You don't want to do anything with this equation. You want to steal its slope and move on. Just steal it and go. You're a pirate looking for slopes. You take its slope and you're out of there. So we have a y equals mx plus b. We're going to substitute what we can, which is the slope goes in here. We're going to put this x right here, and we're going to put this -4 right here. The only thing we don't know is the b, but we'll figure it out here momentarily. So my y value is -4, my slope was -3, and my x value is +3. The only thing we don't know is b. But we can multiply -3 times 3. So we have -4 is equal to -9 plus b. We add 9 to both sides. And we get a finished b value of +5. Now that's not our equation, that's just the b value. We still want this slope and this y-intercept to say y equals -3x plus 5. That equation is parallel to this one because they have exactly the same slope, but it goes through that coordinate, which this one does not. Now, if we wanted to make a graph of it, we could. Quickly grab a piece of graph paper. Alright, the first equation that I had, the first equation was -3x minus 2. So -3x minus 2 would be right here at -2 for the y-intercept, down 3, right 1, down 3, right 1, or up 3, left 1, up 3, left 1, up 3, left 1. So we have an equation that looks like this. And the newfound equation had a y-intercept at 5. So 1, 2, 3, 4, 5. And it also went down 3 and right 1, down 3 and right 1, down 3 and right 1. It would do this forever, or up 3 and left 1. And as we look at those, it sure appears as if no matter how long I go for, these graphs will not run into each other. Now the key was on this last one, the first one I was given, it had to also go through the coordinate 3, -4. So at 3, 1, 2, 3, 1, 2, 3, 4. There's the coordinate 3, -4. Certainly the purple line was given. We made a line that was parallel to it, but also went through the coordinate 3, -4. Perfect. I could have graphed this and counted up and over with my slope until I got to the y-intercept, but it was quicker to substitute it in and solve for the y-intercept.